Hi everyone, welcome back to Cody's Lab. So over here in the background you can see a bottle of deuterium oxide, or otherwise known as heavy water. Deuterium is basically the same as hydrogen, but instead of just being a proton, it also contains a neutron. The neutron doesn't change its chemical reactivity all that much, but it does about double the mass of the atom. And when you make water using pure deuterium, it makes it slightly heavier, by about 10%. Which means you could actually get an ice cube made of frozen heavy water and it will sink in normal water. Now I recently purchased this because back when I was isolating heavy water on my own, I eventually isolated a sample which I believe was relatively pure heavy water, and I ended up tasting it.
Hopefully it's not salty. And also, heavy water is supposed to taste slightly sweet, so let's go ahead and get a taste of that. Well, it's not salty. And it does taste a little bit sweet.
Now, I'm not entirely sure if it tasted sweet because heavy water intrinsically tastes sweet, as I've heard from many people, or if it was the fact that the lead electrodes I was using to electrolyze the water to purify it into heavy water was a contaminant and I was tasting the sugar of lead, which is not particularly good, but the amount I got was obviously not enough to give me any sort of poisoning. Also, I plan to do some neutron activation experiments, and heavy water is the best thing you can possibly have to slow down neutrons, and in order to produce this quantity, it would take me literally years. So I figured I'd save a little bit of time and get a little bit extra so that I can produce those videos sooner. But the main purpose of this video is I would like to taste this and see if it actually does taste the same as what I had originally produced. So I'm opening this for the first time here. This bottle looks very nice. I almost hate to even open it, but well, I really want to know what it tastes like. So let's crack this seal and open this heavy water. Now, heavy water is technically toxic, but only in large quantities. You see, heavy water, deuterium oxide, does form naturally. Normally deuterium is very rare, existing only about 1 in every 6,000 or 7,000 hydrogen atoms, which means this tank behind me would contain roughly 20 milliliters worth of heavy water. It's only if you replace more than about 20% of the water in your body with heavy water before it starts becoming toxic, because the deuterium, the heavy hydrogen, the chemical reactions happen a little bit slower, and so if you get too much of it, chemical reactions in your body may not work properly. So, let's get me a little drinking cup here. How about a fresh test tube? So I got my clean test tube here. Let's take some of this heavy water and pour it in. Let's take about the much. That looks like 5 milliliters or so. Okay. So now, I know a lot of you guys may ask if heavy water is radioactive, and it is not, even though if it was, the radiation probably wouldn't make it through the glass. But this heavy water has not been in a reactor, so I wouldn't expect it to be radioactive anyway. It may contain a little bit extra tritium than normal water would, because the concentration process would probably also concentrate the tritium, but the amounts that are here are still negligible. So I'm not really worried about radiation from it. Tritium is hydrogen, just like deuterium is, but instead of just one extra neutron, it has 2 extra neutrons. So there's 3 different nucleons in the nucleus of the atom, which is why they call it tritium, for 3. Tritium is radioactive. In fact, it's very radioactive. I have some little phosphor-coated glass tubes that have some tritium gas inside of them, and that's what I used in the intro to this video. The radiation actually makes them produce light, which is pretty awesome. Give that a little smell. It smells just like water. There's no real difference there. It's not significantly heavy enough that I could tell any difference from sloshing around. So let's give it a taste. Okay. It actually does taste sweet. And it's about the same as that sample that I had back when I was isolating it myself. That's a good sign. That means it wasn't actually lead. That's cool. Heavy water does taste a little bit sweet. It's almost like, you know how like hay or grass, the sweetness, like if you take some of that and chew on it, it's almost like that. It's got like that slight musky flavor to it as well. Well, that's interesting. So I've roughly doubled my concentration of deuterium in my body, which shouldn't be harmful at all. Like I said before, that even if I drank this entire thing, I would likely still be completely fine. That was roughly $5–10 worth of deuterium oxide I drank there. So it's not super expensive, but it's still, you know, an entire bottle cost over $100. Okay, so here I am 24 hours later, and obviously I'm not dead. In fact, I've been doing quite well. I haven't exhibited any signs of radiation poisoning or anything like that, so I think I'm good. One thing I have been doing is I've been saving my urine because it will contain a higher concentration of deuterium, probably for the next week or so. And I thought, well, I may as well save it. I'll probably distill it off and add it to my electrolyzer if I ever tried to produce massive amounts of hydrogen again. So the heavy water had a very obvious sweet taste to it. The musky taste that I mentioned is possibly due to the fact that this water has been sitting in this jar for who knows how long, and maybe it's gone a little bit stagnant. But it's definitely tasted sweet to me. Now the question is that just like some placebo effect? You know, I know how strong the placebo effect could be. Maybe it's because I heard that it was sweet, and then when I tasted it, it's my brain's just making it sweet. So I'm going to do a little test here. So I have two test tubes, one with heavy water and one with just normal distilled water. Now I'm going to see if Kangen can tell them apart. So Kangen, want to come taste some of this?
Alright.
See if you can tell which one's the heavy water. Can you sit over there?
Over there. Okay. I'm gonna hurt your plant. Okay. Okay. So, do you want to make...
Just taste them. Don't drink too much of it. Just in case it is radioactive. Go ahead.
Just in case it's radioactive, huh? Alright. And this tasted like water. Yeah, that tastes sweet.
And that's the heavy water.
I got it right?
You did. So it does seem that heavy water does have a different taste to it. The question is, why? Why would it actually have a different taste? And why would that be sweet? Does your taste buds like have a diffusion, like the water go in and out, and it's slightly different with the heavy water because of the higher mass? Because really the only thing different is the mass of each particle. So
I don't know, man. But it's definitely sweet.
So it's definitely sweet, huh? So this means that either heavy water is actually sweet, or the source I got it from somehow has a contamination that caused it to be sweet, and it was the same with both my process and the Girder sulfide process.
So what, lead?
No, the Girder sulfide process wouldn't have any lead anywhere in the system.
Okay.
But my electrolysis did. And lead, I think, is the only thing that would be potentially sweet. So my guess is heavy water does actually taste sweet. Kangen had no idea which of these tubes had the heavy water, but she was able to determine which one it was almost immediately on tasting it. So that tells me that heavy water does have some difference in taste. So I've tasted this a few more times, and I've gotten a pretty good idea of how it tastes, and it definitely has a slight aftertaste to it, which I didn't mention earlier, and also it feels cold on my lips. Now, at first I thought that was because it was actually cold, but now that I've compared it to the just plain distilled water, it didn't really have that. It's a subtle difference, but it's still there. The coldness to it, that was kind of surprised me, because I would expect it to be, maybe feel even slightly warmer because it has a slower evaporation. It's the evaporation that carries away energy and makes it feel cold. But when I put some of this on my skin, and I do the same with the normal water, and I blow on the back of my hand, the heavy water spot feels slightly colder. Now, maybe this is also something in my head, but I'm thinking that it's not. And I think I have a theory as to why this might be. You see, heavy water having higher mass per molecule, it takes more energy to get it to evaporate, which you'd think would make it evaporate slower. But there's other things than just the vapor pressure that cause liquids to evaporate, such as surface area and how dry the air around it is. Possibly if those two effects are more significant, it would make the evaporation rates about the same, but the heavy water would be carrying away more energy, making it feel colder. Yeah, just another little thing I've noticed from doing this experiment. There's definitely a lot more research that could be done here, and I'm frankly surprised it hasn't been done. Doing a Google search on this, I find very conflicting results. But yeah, so I wanted to try one more experiment. See, I have an ice tray here with some ice in it. This one is regular water ice, normal tap water in fact, and tastes just like ice should. Now this piece over here is some heavy water ice. So it's still tastes noticeably sweet. Doesn't seem to taste as sweet though. It's almost like maybe my sense of taste is dulled from the cold. That's probably it. Actually tastes rather good though. Okay, so there you go. Let's see. They're both at their melting point because I've held them out for a little while. The ice cube, that feels very cold. The heavy water ice cube still feels cold, but maybe slightly warmer, which would make sense. And this is interesting. I can actually touch the ice with the deuterated. So, dry my fingers off. Now I add the deuterated water to my skin, and I'm going to touch this ice cube, and it sticks right to it, because the deuterium water freezes. Okay, so here's an ice cube at its melting point. Dry my fingers off, get some heavy water going, stick it to it. See, normally it doesn't do that. That's cool. Like usually in order to get that to happen, the ice cube has to be colder than the melting point, but since it's at the melting point, it is colder than the melting point of the heavy water. See, if I do the same with some normal water, no result. If I do with the heavy water, freeze. Oh, that's cool. It like sticks strongly too. Hope y'all enjoyed. I'll see you next time.